we're looking here, we can divide this into kind of two different problems. So in this case, what is rho d? Or what is rho? What is the function?
2r squared plus r plus 3.
So rho, I'm going to write rho of r would be 2r squared plus r. So if we want to find particular solutions here, we have two different guys we're going to look at. So first, can we write this in this form?
But can we just, we can split those up?
Yeah, I mean this form. We write this in this form?
Yeah. E to the 0.
So this is going to be 1 times e to the 0. So what is r in that case?
1. Oh, 0. R is
0. Right, so r is going to be 0.
You don't want to do it that way.
And so we get, what is rho of 0?
3.
3.
1/3.
And so a is going to be 1. So we're going to get, for this particular guy, the solution is going to be a, for this case, is 1. E to the 0, which is going to be 1 over rho of, that's the exponent that we're using, which is 0. It's going to be 3.
So any constant you can find a particular solution through the exponential response form.
Yeah.
It would just be a.
Anything except for like
We just put 0.
polynomial, pretty much.
Yeah. So now if we're looking this guy here, what is A, what is R? R is looking at it for this
R is
part.
going to be 2i. A is 1.
So R is 2i, A is 1. So this part of the solution is going to look like this. So it's going to be 1 times e to the 2i over rho of 2i. All right. So what is rho of 2i? We're going to square 2i. We're going to get -4. So -8 plus 2i plus 3. So this is going to be 2i. So this is the particular solution here. So I mean, this is how we do exponential response. So just figuring out what this guy is, what this guy is.
Is that an okay form to leave it in?
Sorry?
Is that an okay form to leave it in?
Yeah. I mean, you get rid of all those ones and stuff. Yeah. Okay. So yeah, I think that's all that you guys need for the problem set. Again, every problem that you're doing, there are 10 different ways of doing everything. Unless it says explicitly to do a particular approach, then don't really stress which way to go. Yes, ma'am?
For problem 14, I literally don't understand what the question is asking me. Like,
Which one is 14?
A driven mass spring dash pot system,
Right.
and I don't know what the amplitude of the response is. Like, I don't know what.
First page.
Like, is that when you? I understand how to find like
Oh, okay. So
the x particular and the x general, but I don't know what the question is asking me to find.
So we have, actually you can use this here if you want to. All right, so we have a differential equation that looks like, T. A over omega. Okay. Alright, so if we do this, there's a. Let me get this guy here, right? We're going to get some exponential guy, right? That, and the frequency of the transients isn't going to be omega in general. No, it's not going to be the same as omega. So you're going to have some, the complementary solution is going to have some omega naught, right? So you'll be able to write down the final solution by combining the solution to this guy to using undetermined coefficients to figure out what the solution of this guy will be. And you'll get the total amplitude in front of the guy will be a function of both kind of omega and omega knots. So omega knots going to be some constant value that we're going to figure out from this. Then it'll be just a function of omega.
How do we find omega naught from the homogeneous half? I don't.
Solving this. Just from the, so I'll do an example. Do a quick example. Try not to do something super similar to this.
I don't know
So let's say we have,
Christmas, did we do something like problem 14 in class?
Yeah.
Which one?
so,
Okay.
let's take one slide.
It's problem 14. Oh, yeah.
Grab
He
one.
did that at the last lecture, right? Or two, with the big square root.
He's going over it now.
And it was also in one of his online course notes.
So let's say we have something with form.
Because we would have written down.
Alright, so choose one that looks like. Alright, this is, do something slightly different, same idea though. So do something that looks like this. So if we get us to this guy here, which should work out nice. What is the homogeneous solution here going to be?
R minus 3 and R plus 3, so e to the minus
9.
So if we want to write R squared.
possible negative 3.
Plus minus 3i.
So what are the solutions that we're getting for this guy?
3 and minus 3. Minus, yeah.
Alright. So we get x of t equal 1, 2. So what exponents are you getting?
I won't go near that.
E to the power minus
it's
3i.
intervention.
T.
3 negative 3.
Other people
then
that
plus
can't attend
3i.
this recitation want to be able to watch the videos, so stop.
Alright. So if we're looking here, we have
Oh, wait,
our
this is for.
linear solution.
Oh.
So now, if we actually go through and we use undetermined coefficients here, then what will we get for the particular solution here? Or what form should we get for the particular solution here?
A cosine omega t plus b sine omega t.
So I'm going to plug that into here. So we have so we're going to get situation. So we're going to get double dot is going to be minus x squared. is the left side, and we plug this into here. So this is going to be cosine omega t. Alright, so now, what values of, what values of A and B work here?
Can we do the exponential response?
We could make the response small.
Okay. How do we get 9 minus omega squared? How again do we get the 9 minus omega squared? I understand where we get the a sine omega t and.
This is just be 9 times x. So it's going to be 9 times this whole thing.
Okay, and then
So
we'll.
it's 9 times this whole thing, and then we take the second derivative, and it's going to be minus omega times this entire. We're adding them together. So this root is going to be 9 times this.
Why are both of them times negative omega squared?
Yeah.
Like,
Why they
the
both
sign
are?
doesn't become.
What? I don't get it.
So if we differentiate a sine omega t, we
Differentiate
get
twice.
minus omega
Oh, so
squared.
you just took a derivative of x of the
Oh,
particular
that's-
solution, and then he applied the product rule and did a little reorganization.
Skip it.
Oh.
So whenever you take the second derivative of this guy here, it's just
Yeah,
going to be
no,
minus omega squared.
I'm with you now. I didn't realize I was like.
Oh, sorry about that.
Yeah.
Yeah, I didn't see that.
Okay, that makes
Sorry,
perfect
sorry.
sense.
So yeah, so this for this guy here.
So the double derivative of that is negative omega squared.
Yeah.
So many steps.
Wow.
So what forms of A and B do we get?
A is 0, B
B
is
is
not.
9 b
Are you
cosine
seriously
omega
mad, or are you
t
just
minus omega squared b cosine omega t
I
equals
just
80
don't like
cosine
messing
omega
with
t.
something that other people need to use.
Okay, because the light is kind of short, so I get mad over
We'll
stuff.
find it off in
No?
No, I enjoy being mad at stupid things.
What if he thinks of mathematics?
Hey, relax.
He talks in mathematics. I think what he uses when I'm that program. So he knows every in and out of that thing.
It's his.
Yeah, and there are full classes on how to use mathematics software. And he probably like,
so now if we're looking at this one has some kind of initial
knows
conditions.
exactly what the flaws are.
So you're given that.
I'm too special.
Yeah, we're given that. X is 0. So if this is the case, if x is 0 is, yeah, so what are the values of C1 and C2 here?
What was the question?
What are the values of C1 and C2 here?
Oh, plug them in. So cosine goes to 1. And so it's that. And then that goes to C1 plus C2 plus 80 over 9 minus, wait, omega equals
So
0. And you can take the derivative of that as well.
It's easier to say, okay.
uh,
And solve for the two equations.
yeah. Easier way of doing this. Alright, so we're gonna get that C1, C2, zero, C2. So.
Sounds like water drops. Thank you. Wait, what? Are you okay? That's all right. Yeah, what does he do?
This is good. All right. So, it's going to get slightly tricky. So I tried to make this problem, take the problem that was here and turn it into a function of omega. It's probably a bad idea. This one was actually given in the form omega equals 5. And so if that's the case, so actually this term is not that bad to deal with. It's going to be, what's that, 20 minus 9, so 16. Yeah, so this term here is just 5.
Minus.
Right?
Minus
Yeah, minus 5. And so we can solve for what C1 and C2 are. And C1 and C2, so that's minus 5, yeah. In which case we'll be able to convert this into sine or cosine situation of some sort. And from there we'll be able to combine this term with this term and we'll have an exponential. And the exponential will be in terms of omega. This particular value is not the best to choose for that.
So then, what is the amplitude of the response? What is that in that equation with the particular and the homogeneous solution?
So
What is it? Is it the 80 over 9 minus omega squared, or do we have to combine the particular solution with the homogeneous solution?
No, it'll be the combination.
It will be the combination
The whole
of.
thing will be the amplitude, the general solution.
Yeah.
So like when you combine, when you put the the solution, the homogeneous solution from like your e exponential form and into the cosine form,
Right.
and then you add that together, then like the constant that you multiply cosine by, is that the amplitude?
Yeah, the thing that's in front of the single term be there. Should be in terms of omega. Yeah.
Okay. Okay. That makes more sense. Because I just didn't understand what the phrasing of the question was. I didn't understand what they were asking us to find. I understand like procedurally how to find it. Just didn't know.
Yes, no, it's just the amplitude will be a function of omega. The amplitude in front of the combined term will be a function of omega. So, are there any other questions from problem set-ish type topics? So, if not, then we can start talking about, we've kind of done driven things before. What examples did you guys actually go over yesterday? Did you guys go through any real-world examples of sinusoidal driven solutions, either yesterday or one of the previous lecture? So,
We did. What do you mean real world? Like word problem or like?
no. So you guys have done spring systems, right?
Yes.
Have you guys done circuits? Have you guys done?
No.
We haven't done any of that.
Okay. All right. So let me give a brief introduction to the beginning of what we're going to do with circuitry. We're going to get a bit more in depth a little later on. Start talking about complex responses. But the introductory idea here is that we have a system.
What's just the wavy thing?
This.
No.
This?
No.
Oh, it's a source. It's our battery. It's kind of like plugging into the wall thing. So it's not going to be a straight 9 volts. It's going to be,
So it's an alternating current.
yeah, it's an AC source. So, all right, so we have a circuit. So in 802, we will deal with exactly what the details of a system like this actually are. But for now, just know that we have these things connected by wires, and they're in just one piece. All right, we call this an RLC circuit because there's an inductor, a resistor, and a capacitor. We have the voltage across each thing. So the voltage across the battery, in this case, is going to be of some form sine A sine omega t. All right, so it has some height to it. The current, sorry, the voltage across a source here. The voltage in the capacitor is going to be L di dt, where L is constant. Voltage across the resistor is going to be IR. And the voltage across the capacitor is going to be
Huh? Didn't you just...
Q over C.
Sorry, what's the difference between the